Hello, in this video we're going to be looking at the relationship between the radius of a planet and the time it takes to orbit. Kepler worked out that if you take the time it takes for an object to orbit, in this example Mars, and then you square that value and then divide it by the radius of the object cubed, then you get a constant. And if you take another object orbiting the same body, so here we have Jupiter orbiting the Sun, and you again take the time it takes for Jupiter to orbit and you square that, and then you divide it by the radius of Jupiter's orbit cubed, then you get a constant. And due to the fact that they're both orbiting the same body, in this case the Sun, then the two constants are equal. And this is important in being able to find out the period of an orbiting object. Here we have some data about two moons of Saturn, Mimas and Rhea. We are missing the orbital period of Rhea, which we need to calculate. So firstly, we'll start with the moon, of which we have the full information for, which is Mimas. So using Kepler's third law, t squared over r cubed, we can see the orbital period is 0.9, which we need to square, and then we'll divide it by the radius of the orbit, 195,539, which is cubed. Working that out gives us the constant 1.268 times 10 to the minus 16. We then need to work out Kepler's third law for the other moon, Rhea. Now we don't know the orbital period, so we're going to leave that as x squared for the moment. But we would divide that by the radius, which is 527,108 cubed. Now, because we know that both the moons are orbiting the same body, in this case Saturn, we know that the constants will be the same. So the constant for Rhea will be the same as the one we just worked out for Mimas, which is 1.268 times 10 to the minus 16. We can then rearrange the equation just by doing the opposite. So to bring over 527,108 cubed, instead of dividing it, we would multiply it. So this gives us the x squared equals 18.573. It's important to remember not to stop there. This isn't the value of the orbital period, it's the value of the orbital period squared. And so therefore we need to do the opposite again. And so to get rid of a squared, you square root to get the value of the orbital period, which works out to be around 4.3 days. So now you're confident using Kepler's third law to work out the period of an orbiting object. Have a go at some of our key questions.